All right, guys, for these videos, for these problems, I should say, we want to find the vertex and the axis of symmetry of the graph for the function. These ones are all conveniently in vertex form, so this actually makes the problem very easy, okay? If I look here, I want to know what my h is and what my k is, because remember, vertex, the x value we also call k of a vertex, and I'm sorry, h, and then k is the y value of the vertex. If it's in vertex form like it is here, notice that this is kind of the h, and there's no k here, and we'll talk about what we do in this case. All right, so let's backtrack a bit. Here I can find my h. It looks like a -2, but it's because of the formula, and it's actually a +2. If we were thinking about translations or how this shifts, this would move your graph 2 units to the right. Now, I don't have a k, but if I put a +0, I can think about my k being equal to 0. Okay, so that's my y value of the vertex. If I'm thinking about the transformations, it doesn't go up or down. All right, so putting those two things together, my vertex then is 2, 0. Now your axis of symmetry, a little bit of review here. Your axis of symmetry is a line that goes through x, and specifically it goes through your vertex and happens to be the same thing as our x value of our vertex, since it does go through the same point. So if I know my h, and in this case I do, then my axis of symmetry is just x equals h, in this case x equals 2. Okay, so let's go through all the other 3 real quick. Looking over here, what's my h? It looks like -1. It's actually +1 because it's in the parentheses and because of that form of the minus in front. This one here, I do have a k. This time it's 4. Put those two things together. My vertex then will be 1, 4. And then just like how we set up here, my x will be the equal to h for my axis of symmetry. So my axis of symmetry is going to be x equals 1. All right, so if you see problems like this, I mean, it helps to know how to do them, but if you know how to do them, these problems are actually going to go through rather quickly on your test. So in this case here, I don't have a k, and actually let me tweak this problem up, but I mean, let's go through real quick. H would be -8, k would be 0. So my vertex then is going to be -8, 0. My axis of symmetry is going to be x equals -8. Okay, now I didn't give you an example like this, but if you saw one that said f of x was equal to -4x squared plus 8, this one is different. I could have written this as -4 times x plus 0 squared plus 8. So really in this case, my h is equal to 0 and your k is equal to 8. Okay, and then you would go from there. Over here, your h is equal to -1, your k is equal to -5. Putting those things together, your vertex is -1, -5. Your axis of symmetry is, x is equal to -1. Okay, so we went through 4 of them, even actually a 5th problem rather quickly. Let's talk about this next part of how to tell a function if it's, or at least how to tell if a function is linear, quadratic, or exponential. Okay, so if it is linear, then it will have a common first difference. Okay, what we mean by first difference is you look at the changes in the y's. If the y's change by the same amount, it has the same first difference, therefore it will be linear. Okay, so you check this, and we'll get into it in a second. I guess I'll just write about it here. And put it into your words, but we look at the change between the y's. All right, and to kind of show you what I mean here is if I look at this one down below, From 7, and my y's are this bottom row, by the way. From 7 to 4, it's minus 3. And then from 4 to 1, it's minus 3. From 1 to negative 2, it's minus 3. And from negative 2 to negative 5, it's minus 3. These are all the same. Okay, so they are linear. Okay, and it's because they have a common first difference. Okay, and we did that one in class. To check if it's quadratic, it will have a common second difference. Okay, now you wouldn't check if it was quadratic if you already determined that it was linear. Okay, so the next step was from here, look at the change between the y's. Okay. Then compare the change between these. Okay, so we'll have to clarify that a bit more, but in this case, let me give you an example of a quadratic function. Let's say negative 2, where this is x, this is y. Negative 2, negative 1, 0, 1. Okay, and then say I've got, let's see, negative 4, negative 1, 0, negative 1. If I look at the first difference between my y's here, negative 4 to negative 1 actually goes up 3. Negative 1 to 0 only goes up 1. And then 0 to negative 1 actually goes down 1 again. Okay? So this one would not be linear because they don't have a first common difference. But I check for their second common difference. If they have one, from plus 3 to plus 1, that actually goes down 2. Positive 1 to negative 1, that goes down 2. And then you probably have a few more points to kind of compare. But this one would have a second difference. Okay, so we're looking at the first change between the y's. If they're not the same, then I look for the change after. I do the same test one more time. If a function is exponential, it will have a common ratio. Okay, you can check this by seeing if your y's get multiplied by the same number every time. Okay, and then of course all of these put in your own words. As long as it's in the right ballpark, you will get full credit. Let's check out these. Let me do this one here because this one will actually be an example. This one, you times it by 2. Here, times by 2, times by 2, times by 2. That is an example of an exponential function. Okay. By the way, if one is linear, it's not going to be quadratic or exponential. Or if one was exponential, it's not going to be quadratic or linear either. Okay. Let's check out these two here, though. And by the way, if it's not one of those three, it's just put neither. Okay. And if it happens to be neither, it might be something else, but it's just not one of those three. So if I look at the very first one, if you can tell right away that it's getting multiplied every single time, you probably go straight to that. When we looked at the example here, you could probably see that it's being doubled fairly easily. If not, go straight to linear and quadratic functions to see if they have a difference. From 7 to 4, it goes down 3. 4 to 1, it goes down 3. 1 to negative 2, it goes down 3. And negative 2 to negative 5, it goes down 3. So it has a first common difference. Therefore, it's linear. Okay, let's check out the next one. This one here goes down 4, down 2, actually up 2, and then up 4. So these are not the same, so no first common difference. Let's check out the difference of those differences. This one here is going up 2. Oh, this one here actually goes up 4. And this one, where are we at here? Oh, this one here goes up 2. Okay. This one doesn't have a second common difference either. And if I check, really you would have to multiply 6 by 1/3. And if I multiply 2 by 1/3, I don't get 0. So this one won't be exponential. It's not a first common difference. It doesn't have a second common difference. So it's neither/none. Okay. Let's see. Do I want to put the next one? And I will put the next one in a video. The next